Traditionally, recording engineers have always been taught that one of the mistakes you can't recover from is allowing a recording to be clipped, to overload at some stage, cutting off the tops and bottoms of the wave, in the process creating unwanted distortion harmonics that become part of the signal. In the analog era, people played fast and loose with this thanks to the pleasant warmth often introduced by tubes and transistors in very slight overload. But in the digital era, the unforgiving harshness of analog-to-digital converters clipping renewed the caution that clipping is an unrecoverable error, which, thanks to Murphy's Law, is most likely to happen at the worst possible time, for example, ruining that magical first take that the artist will never be able to repeat. Well, RX's D-Clip module is capable of changing the game. While I'd still strongly advise anyone to studiously avoid clipping, especially digital A-to-D clipping, if it does occur, there may in fact be a remedy, and D-Clip is it. D-Clip works like an automated version of the DAW technique of employing the little-used pencil tool to draw away a clip on a wave, restoring the proper top and bottom shape, which will in turn effectively remove at least most of the unwanted harmonic distortion components that were added to the wave, eliminating the distortion in the process. Anyone who's ever done that knows that it definitely can work for isolated clips, but that having to do it manually on a long series of clipped wave cycles would be tedious and time-consuming enough to be impractical. RX8's D-Clip module automates this process, however, and that makes it very practical and very often highly effective, not to mention fast and efficient. Here's an audio file, a vocal melody, that was somewhat clipped at the ADC, the analog-to-digital converter.
Picked myself up from the pavement once more, and I swore this time that's enough.
If I zoom in, you can see the clipped peaks clearly. What you need to do is tell D-Clip which part of the wave it should smooth out. In other words, help it to identify the clipped peaks. To do this, you set a threshold. Lower that threshold to a point just below the clipping point, maybe a dB or so D-Clip knows how much of the wave to process. The Suggest button will try to calculate the most appropriate threshold setting for you, but for this recording I took it down an extra dB. D-Clip offers a quality option, high, medium, or low quality. For most simple clipping, the low quality option should be just fine, but if you preview the processing, an option available in all the modules, and you feel low isn't doing the trick well enough, medium or high should provide better results. I'll use the highest quality processing module.
Picked myself up from the pavement once more, and I swore this time that's enough. Picked myself up from the pavement once more, and I swore this time that's enough. Picked myself up from the pavement once more, and I swore this time that's enough.
So, on this particular bit of audio, it worked. I exported the declipped wave and brought it back in to another session so you could see the repaired peaks. There are a few other controls in the declip module. The link symbol lets you set the clipping threshold for the top and bottom of the wave in tandem. It's on by default, but if you had a wave with asymmetrical clipping, you could disable it and make those settings independently. Makeup gain is pretty self-explanatory. There's a peak limiter available to apply to the repaired audio. It's on by default, and you should normally leave it on. D-Clip repairs the audio by reconstructing the estimated original shape of the wave above the clipping point, and this may exceed 0 dBFS, which is probably why the wave clipped in the first place. You'll need to have the limiter on to keep the repaired signal's peak levels at a safe margin below that point. Normally, it shouldn't affect the overall level of the audio file, say within a mix. Next up, modules that address typical voice issues.